I'm Algebra Annie, and I'm here to help you be successful in your algebra class. If it doesn't challenge you, it doesn't change you. Fred DeVito. Our learning target today is, I can solve inequalities that contain more than one operation.
Today we're going to be solving two-step and multi-step inequalities. So we are supposed to solve this inequality and graph the solution. We solve inequalities very similarly to solving equations. It's going to be the order of operations, which was GEMS, but we're going to go backwards. So if this were an order of operations problem, the first thing we would have done was multiply, and then we would have added. We're going to go backwards so we can solve for F. So the first thing we need to do, if we're going backwards, is this 160 needs to go away. You pair 160 with negative 160. 160 minus 160 turns to 0. I'm left with just my 4F is less than or equal to 500 minus 160 is 340. I'm going to divide both sides by 4, but I need to stop and I need to remember I am dividing by a positive. If you divide by a positive, this means that you do not reverse. So my symbol is going to stay the exact same. 4 divided by 4 is 1, so I'm left with F is less than or equal to 340 divided by 4, which is 85. So I'm graphing F is less than or equal to 85. So here's my number line. The number in question is 85. It is closed because there's an equal to symbol, so we're going to color it in because it is closed. You need a few numbers to the right, and you need a few numbers to the left. I'm looking for all numbers smaller than 85. Well, I know that 84 is smaller than 85. 84 is right here, so I'm going to color in the direction of 84, and that is my graph. So F is less than or equal to 85, and here's the graph of F is less than or equal to 85, and you're done. The next inequality that we're going to solve and graph, remembering we solve using GEMS backwards. So if this were an order of operations problem, like we did at the very beginning of the year, the first thing we would have done is multiplied, and then we would have taken care of the subtraction. We have to go backwards. So first let's go ahead and take care of the 7. This is a positive 7. You pair a positive 7 up with a negative 7 to make it disappear. 7 minus 7 turns to 0, so I'm left with this negative 2t is less than or equal to 21 minus 7 is 14. I want to get the t by itself. T is stuck to the negative 2 by multiplication. We undo multiplication by dividing. The number that is stuck was a negative 2, so I'm dividing by negative 2. I chose to divide by a negative, so I need to stop and remember. This is actually a negative number that I am dividing by. If I remember from our last lesson, if you divide by a negative, you need to reverse the inequality symbol. So I'm no longer less than, I am now a greater than or equal to symbol because I divided by a negative number. Negative 2 divided by negative 2 is 1. I'm left with t is greater than or equal to 14 divided by negative 2 is a negative 7. So I am graphing t is greater than or equal to negative 7. So here is our number line. The number in question is negative 7. It is equal to, so it is a closed colored in circle. I need a few numbers to the right and a few numbers to the left, being very careful because negatives confuse a lot of students. I need a number larger than negative 7. Well, I know 0 is going to be larger than negative 7. I know my 0 would be way over here on the number line. So I'm going to color in the direction of 0. And I'm done. So this is the answer. T is greater than or equal to negative 7. And this is the graph. T is greater than or equal to negative 7. And you're done. We need to solve our next inequality using the same method. We're going to do the order of operations backwards. I see a giant fraction problem. If you remember the giant fraction problems, we treated the division giant fraction as a grouping symbol. And that grouping symbol told us to go to the very top and do him first. So we would have done the very top first, and then we would have treated it like a fraction. So then we would have gone ahead and divide. We're supposed to do order of operations backwards, which means this is the first thing we need to take care of, is the divided. So I am going to multiply both sides by the divided negative 2. So I multiply both sides by negative 2. I multiplied by a number, so I need to stop and think, is this positive or negative? I multiplied by a negative number, which means I need to reverse my inequality symbol. So my inequality symbol is now pointed the other direction. A negative 2 divided by negative 2, so I'm left with x plus 5 is less than 3 times negative 2 is a negative 6. Now I can subtract 5 from both sides. Positive 5 minus 5 turns to 0. I'm left with x is less than negative 6 minus 5 is a negative 11. So I'm graphing x is less than negative 11. So here's my number line. Negative 11 is the number in question. Not equal, so it is open. It is not colored in at all. I need a few numbers to the right, and I need a few numbers to the left. Remembering negatives are backwards, so be very careful. I need numbers smaller than negative 11. I know on negative numbers, the further you go to the left, the smaller they end up getting. So I know that I need to color in this direction. And I'm done. The answer is x is less than negative 11, and this is the graph. X is less than negative 11. So this is the next inequality we're supposed to solve. I see that I have numbers in two separate groupings on the same exact side. So if you were to actually separate this, like we used to do when we first learned how to solve real equations, I really don't know what I have over here. I have negative 4 minus 8. So what do I actually have on this side of the problem? I actually have negative 12. And everything else is the exact same. So I haven't done anything. I just try to figure out what do I really have over here. I have negative 4s and negative 8s. Can't have two separate groupings, so I put them together. Now I have a problem that I need to solve. If this were an order of operations problem, the first thing you would have done was multiplied, then we would have taken care of the subtraction. We have to go backwards. So we're going to take care of this negative 2 first. You get rid of a negative 2 by pairing it with a positive 2. Negative 12 plus 2 is a negative 10. It's a less than symbol. We didn't do anything to the negative 5c. A negative 2 plus 2 turns to 0, so he disappeared like we wanted him to. I want the c by itself. C is connected to the negative 5 by multiplication, so we undo by division. The number that is stuck is a negative 5, so I'm dividing both sides by negative 5. When you choose to divide, you need to make sure that you look and see what kind of number it is. This is a negative number. If you divide by a negative, you have to reverse the symbol. So my inequality is now pointed the other direction. Negative 10 divided by negative 5 is a positive 2. I had to reverse the symbol because I divided by a negative number. Negative 5 divided by negative 5 is 1, so I'm just left with c. So I'm graphing 2 is greater than c. So here is my number line. 2 is the number in question. It is not equal, so it is not colored in. This is actually an open circle. I need 2 to the left. I need 2 to the right. So 2 is supposed to be greater than all the numbers I color in. I know 2 is bigger than 0. So I should color in where 0 is, because I know 2 is bigger than 0. So you would color in this direction. Another way you could do this, you could flip-flop this inequality, and it would still be the same graph. Some students have a very hard time graphing when the variable is on the right side. So if you completely pick it up and flip-flop it over, you would get the same answer, but you can read it differently. So if you were to completely flip-flop it, C, 2, they switched sides. Now the inequality was pointing to the C. The inequality still points to the C. It's the same answer. Just sometimes students like reading this one easier than that. So all the numbers that are smaller than 2. Well, what numbers are smaller than 2? I know 0 is smaller than 2. I colored in 0 as an answer. Same exact answers, same exact graph, because it's the same answer. Just some students like reading this one easier. And you're done. So our next inequality that we need to solve for, I am going to go ahead and divide both sides so I make sure I keep things separate. On the left over here, I actually don't know what I have. I know I have negative 3 groups of this parenthesis. So the first thing I need to do is I need to distribute this negative 3 into my parenthesis so I can see what I'm actually dealing with on this side of the problem. So negative 3 times 3 is a negative 9. Negative 3 times a negative x is a positive 3x. So on the left side of my problem, I actually have a negative 9 plus 3x. This is a less than symbol. I actually don't know what I have on the right side. 4 squared. What is 4 squared? 4 squared is actually 16. So this is the inequality I'm solving for. I've discovered what I really have on my left, and I've discovered what I really have on my right. If we were to solve this using an order of operations problem, the first thing you would have done was multiply, and then you would have gone ahead and you would have added. We have to go backwards. So the first thing that needs to go is this negative 9. What do you pair a negative 9 up with to make it disappear? You pair it up with a positive 9. So we're going to pair positive 9s on both sides. Negative 9 plus 9 turns to 0. I'm left with this positive 3x is less than 16 plus 9 is 25. Now I need to get the x by itself. X is connected to the 3 by multiplication. We undo multiplication by dividing. The 3 is who we need to divide by because he's what is stuck to the x. Before we go further, we need to stop and think. I just divided by a positive number. If you divide by a positive, you do not reverse. So my symbol is going to stay the exact same. 3 divided by 3 is 1, so I'm left with x is less than 25 divided by 3 cannot be simplified any further. So he is the fraction 25 over 3. But I know that I have to graph this. And the fraction 25 over 3, I actually don't even know what that is. It's kind of hard to graph. So I need to go ahead and I need to divide it. I know 25 over 3 would give me 8 and 1/3. So I am graphing 8 and 1/3. So here is my number line. Since I'm graphing fractions, this is 8 and 1/3. And this would be 8 and 2/3. If I had one more third, I would have been at 9. If I took away a third, I would have had 8. Take away another third, I would have been at 7 and 2/3. Not equal, so it's not colored in. This is an open circle. I'm looking for numbers smaller than 8 and 1/3. Well, I know 7 is smaller than 8 and 1/3. 7 would have been over here, so I'm going to shade in the direction of 7. So my answer is x is less than 8 and 1/3. This is the graph. X is less than 8 and 1/3. And you're done. So now we're going to do a fraction problem. I know what I have on the left, and I know what I have on the right. So there's nothing I need to simplify before solving the problem. If this were an order of operations problem, the first thing I would have done was the multiplying, and then I would have taken care of the added half. We have to go backwards to actually solve the problem. So here's me keeping my items separate. I pair a positive 1/2 with a negative 1/2. A positive 1/2 minus 1/2 turns to 0. I'm left with my 4/5 x is greater than, I need to know what 3/5 minus 1/2 is. So 3/5 minus 1/2. I'm going to have to try and find common denominators. So a common denominator between 5 and 2 would be 10. So my common denominator is going to be 10. It's a subtraction problem. I multiplied 5 by 2 to get this 10. So 3 times 2 is 6. I multiplied this 2 by 5 to get that 10. So 1 times 5 is 5. So now that I have common denominators, I can go ahead and subtract my problems. So I have 4/5 x being greater than. If I had 6/10 and I took away 5 of those tenths, I was left with 1/10. Now I need to get x by itself. X is stuck to the fraction by multiplication. You undo multiplication by dividing. So I'm going to divide both sides by the fraction 4/5. That needs to go away. 4/5 divided by 4/5 simplifies down and gives me x. I divided, so I need to stop and I need to think. I divided by a positive number. If you divide by a positive number, you do not reverse your symbol. So the symbol stays greater than. Now I'm supposed to be trying to divide. I know I had 1/10, and now I'm trying to divide that by 4/5. And now that I'm running out of room, we're going to come up here and write it. This is x is greater than 1/10 divided by 4/5. So I just rewrote it because we had to get more room. Divide fractions is keep, change, flip. And then you could just multiply straight across. So x is greater than 1 times 5 is 5. 10 times 4 is 40. We need to simplify our fraction. I know both numbers have the number 5 in common. So when simplifying my fraction, 5 divided by 5 is 1. 40 divided by 5 is 8. So I'm graphing the fraction. X is greater than 1 over 8. So here's my number line. 1/8 is the number in question. Not equal, so it's a not colored in circle. I need 2 to the right, so I'm going to count by 8s. So add one more 8, add one more 8. To the left, I'm going to count by 8s, so I'm left with no more 8s, and then a negative 1/8. I need numbers bigger than 1/8. Well, I know 1 would have been bigger than the fraction 1/8. 1 would have been slowly coming this way, so I'm going to color in that direction. And I am done. So our next problem, I actually don't even know what I have in this problem. I know that I have two groups of this parenthesis x plus 4, And then I'm supposed to add 3 to it. So I don't even know what I have to start with. So I'm going to go ahead and figure that out first. So first I need to do is distribute the 2 to everything in this group. So the 3 was not part of that group. This is 2x. And then a positive 2 times 4 is a positive 8. This is all greater than 3. I still don't know what I have on this side because I see a whole number and a whole number in 2 separate groups. If I had positive 3 and positive 8 on the same exact side of the equal sign, what do I really have? 11. So I have 2x plus 11 is greater than 3. So this is the problem that I actually need to solve for. If this were an order of operations problem, you would have had to multiply first and then add. We're going to go backwards. So first we have to deal with the positive 11. Positive 11 gets paired with a negative 11 to make it disappear. So we have 2x. Positive 11 minus 11 turns to 0 is greater than 3 minus 11 is a negative 8. I need the x by itself. X is stuck to the 2 by multiplication, so we're going to undo it by dividing. The 2 is the number that is stuck, so the 2 is the number that we are dividing by. We divided, so you need to stop and look. This is a positive number that you chose to divide by. Positives do not get reversed, so we do not reverse our symbol. Symbol stays the same. 2 divided by 2 is 1, so x is greater than a negative 8 divided by 2 is a negative 4. So we are going to graph x is greater than negative 4. So here's my number line. Negative 4 is the number in question, so there's negative 4. Not equal, so it's not colored in. This is an open circle. I need a few to the right and a few to the left, being very careful because negatives count backwards. Number is greater than negative 4. Well, I know 0 will always be bigger than any negative number. If you kept counting, 0 would have been in this direction. So 0 is down here, and I am done. So now we're going to move into a word problem. To win the blue ribbon for the heaviest pumpkin crop at the country fair, the average weight of John's 2 pumpkins must be greater than 819 pounds. One of his pumpkins weighs 887 pounds. What is the least number of pounds the second pumpkin could weigh in order for John to win the blue ribbon? So 819 is the number that he's comparing his pumpkins to. On this side, he has his 2 pumpkins, and he needs the average. If you have 2 things and you want the average of it, you had to add them together and divide by 2. He's telling us that his average, his pumpkins over here, need to be more than this. So this is going to be the tinier number. This is the smaller number. So we need to point to the smaller number. All of this needs to be bigger than 819. So this is the true weight of his pumpkin. So he knew one pumpkin was 887 pounds, and he needs to know what's the weight of his second pumpkin if he wants to be bigger than an 819 pound limit. So we have 819 is less than the fraction 887 plus x, all divided by 2. If this were an order of operations problem, a lot of students see this as a division. However, when it's a division within a problem, we call it a grouping symbol, and that grouping symbol tells us to go to the very top and do him first, and then he could come down and actually do the division. So if we go ahead and do this backwards, we have to get rid of the divided by 2 first. We undo dividing by multiplying, and the 2 is the thing that needs to go, so we're going to multiply both sides by 2. 2 times 819 is 1638. I multiplied by a number, so I need to stop and think. This is a multiplied by a positive. If you multiply by a positive, you do not reverse. So my symbol is going to stay the same. It is less than. A multiplied 2 gets rid of divided by 2. So I have 887 plus x. I need the x by itself. So I need to pair this positive 887 with a negative 887. 1638 minus 887 is 751 is less than positive 887 minus 887 turns to 0, and I'm left with x. So the answer is 751 is less than x. A lot of students have a hard time reading this, so we're going to flip-flop it so it's a little easier to read. So x, inequality opened towards the x, open towards the x, is 751. It is the same answer. I just chose to write it the other direction so it was easier for me to read and graph. So 751 is the number in question. Not equal, so this is an open answer. We do a few to the right, and we do a few to the left. I need all numbers greater than 751. Well, I know 752 is bigger than 751. That is this direction, so I'm going to color it in, and I'm done. So if John is to get a pumpkin, his pumpkins need to be bigger than 751 pounds to make the average of the two pumpkins greater than 819.
What did we learn today? I could solve inequalities that contain more than one operation. And I look forward to seeing you tomorrow in class.